welcome to week of 427. We are entering our third unit now in science, as I mentioned to some of you last week through Zoom. So just a note, I know that you guys do not have this book. This book would have been the next one you would have been given. It was the Unit 3 book on the Earth structure, and that's okay. Don't worry about it. I got you covered. So you'll have plenty. I've got a note packet online that you'll have accessible, so you don't have to worry about not having your book. I have a lot of supplemental materials, and you won't really have to use the book. And if you do, I'll provide you with the pages that you need. So no worries there. So it's okay. I had a lot of people worried about that, but it's all right. This next unit is the one that contains the rocks and minerals, and many of you asked, could we do that before the end of the year? We are going to do it. It kind of stinks because I wanted you guys to use the microscopes and look at the rocks and minerals that way. But I'm going to make this happen, and I'm going to try to be as creative as I can. I did order, I'm very excited, ordered 3 sets of different types of rock, metamorphic, sedimentary, and some other types of rocks. I'll do up close and personal labs so you can actually see them, and we can still do scratch testing and hardness features and all of that. So I'm really excited to get those soon in the mail, so that will be coming. For this week, we're going to focus on the very first chapter in that book, which is Earth's system and the Earth's interior, which will lead us more into rocks and minerals and just pretty quickly. And this part is for lessons 1 and 2. So pretty cool stuff in here. It's really, really interesting. The first thing you guys will learn about and watch there's some video clips I'll have you look at, would be the 4 spheres of the Earth. So we've got the atmosphere, which is the layer of gases that surrounds the Earth. Okay, there'll be, again, another little video and some notes that you'll have access to that'll give you a little more specific information. The atmosphere, again, the layer of gases that surround the Earth. Then we have the geosphere. That's pretty much our hard surfaces, so our rocks that make up like the mountains and our ground and all of that would be our geosphere. And again, we'll talk more about that. Hydrosphere is all of the water, so all of our water on Earth, whether it's a river, a pond, an ocean, a lake, that's our hydrosphere. Hydro, you can kind of see in there when you hydrate, right? You're giving yourself your water, replenishing. And the biosphere is basically anywhere that anything living lives. So that could be all the way at the top of a mountain to down in the deep depths of the ocean. Anywhere that creatures and organisms live would be our biosphere. Bio meaning life, right? So those are the 4 spheres. And again, I won't say too much because there's some cute little cool videos that are coming your way this week that you can watch and get a better idea of what that is. And a little kind of a small project with that I'm going to have you guys do, which will end up being a study tool for the the final exam also. All right, so these are kind of, for lesson 1 and 2, the big things I want to talk about. And again, the notes are very much more specific. You'll use them for an assignment this week too. One of the big parts of this chapter is this talk about geologists. Well, we know that a geologist studies rocks and the Earth's structure and things like that. Well, they don't just study the Earth, they also study other planets to figure out, that's how we know sort of the makeup of Mars that we've talked about a lot and the other planets, is because geologists have been able to try to get, when they can get samples from those areas, then we can study them and know more about the planet's structure and what happened many years ago, how it became that way. Now, you might ask, how does a geologist study the rocks that are deep in the Earth to figure out, again, what happened many years ago, or what's the structure inside the Earth? And we know that because they can do a couple things. They can drill, so they will drill for samples that are deep into the Earth where we can't physically go, and they will bring those specimens up and they actually look at them to determine the structure of what's underneath us, like way, way, way underneath us. Another thing is volcanic studies. So when a volcano explodes, my 2 boys thought this was cool. We were watching a video on it. When volcanoes, so when the lava spews out of there, it also spews out rocks from really, really deep down. It could be thousands of miles down. And that spews out of the top and leaves us with these cool rocks. And those rocks can tell us a lot about what happened a long, 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 long time ago and about the structure of the Earth. Another piece is lab simulation. So scientists can actually bring rocks into a laboratory where they sort of mimic the conditions of the internal part of our Earth, so that super intense pressure and temperature that's inside our Earth, they can simulate that. They can make those conditions in a laboratory and then put the pressure on a rock and see what happens. And that tells them how different rocks react to different conditions. So it gives us a lot of great information about our structure. Pretty cool stuff. Another thing that I put this one in red with a star because it's so important, are the seismic waves. So if you're not sure what seismic waves are, they will measure sort of this underground energy. And you can use something called a seismograph, which my kids and I are making a model that you'll see at the end of the video. And it's actually a little like makeshift model of a seismograph that you can see how that works if you haven't seen one before. What happens for geologists is what they'll look for is once they when they use a seismograph, they're looking to see what happens with the waves. So they'll get a printout of what's going on. And what happens is, you'll notice on this, I drew a little picture of maybe like a different sort of material here in the Earth. And what happens here is the waves are pretty steady. And then what they end up seeing when the waves hit something that's different, a different type of material in the ground, the waves will sort of kind of skew themselves. They'll wrap themselves in a different way. And when they get that output, scientists know that something else is down there. And what type of material is that? And they can actually do a really good job at determining what type of material by looking at the wave pattern. So that's a pretty cool feature too. Again, you'll see more coming on that. An interesting fact I just learned yesterday is that during the Cold War, the United States and the Soviet Union, and some of you may know this, Soviet Union, they were actually testing some nuclear weapons, but they were testing them in the ground. And they were using seismic waves to determine what impact the nuclear weapons had on the Earth below. And without them even realizing it, it actually provided some really important data to geologists about the makeup of the ground. So even though it wasn't their intention to give that information, it gave us some really valuable information. So I did not know that. I thought that was a really cool thing. So all my history buffs out there, a very cool fact, in case you didn't know that one. And the last part that we'll focus on for this week would be the structure of the Earth itself. I know this is not the greatest drawing. So I'm going to try to prepare a 3D model for you guys, but I know you've seen this before of the Earth, where you have the mantle, which is that thickest section, and that is about 3,000 kilometers thick. Very, very, very thick. And it's also made of solid rock that's quite hot. Okay, so that's, again, the mantle, solid rock, quite a high temperature. When we go a little bit deeper, or a lot deeper, I should say, we have the outer core. I've got that in blue. And that is made of molten metal, which means it's liquid. So again, very, very hot. And then the inner core is our solid metal core. A lot of people don't think the inner core is solid, but it is. And what happens is that there's an interaction with the particles in the core that actually is so intense that it doesn't let them become a liquid. Just learned a little bit more about that in a video online too, which was pretty neat. Another thing to note is that if we were able to travel down into the core, what you would find happen is a huge increase in pressure, and that's because the rock is under such intense pressure. And with that, that causes an increase in temperature. So it does get hotter as you're moving toward the core. So that, in a nutshell, like I said, you'll get a full printout of the notes, which we'll use for different assignments, but I wanted to give you sort of the layout of where we're going, and this will lead into some rock and mineral study. And yeah, so that should be it for this week. There will be a few assignments posted online. Some of them you'll send back to me in 365. And again, you'll have the week to complete those, so from Monday to Sunday, released on Sunday morning. Okay? Oh, I actually hear a knock at the door. I think we might have a visitor. Hang on, I'll be right back, guys. Oh my goodness, you all will not believe who is at the door. Come on in, our guest. This is so exciting. I had no idea. Come on in. Ladies and gentlemen, you will not believe it. Oh, please, please have a seat, doctor. Doctor, good. Make sure you're comfortable. You will not believe my guest today. He is the world famous, Dr. Rockendirt. I'm very nervous. This man is just my idol. Can't wait. I'm so excited to interview him. A little nervous though. Oh my goodness. Okay. This man knows all about rocks. He's amazing, and all about the earth structure. So if it's good with you guys, I'll fill him in. We've been learning all about this stuff today. Stuff. Lots of stuff, right? Geologists. Oh, please make yourself comfortable. Yeah, of course, right? Got his legs up. I love it. I love it. Oh my goodness. And he's sitting in my chairs. All right. So Dr. Rockendirt, we've been talking all about much of what you published on the Earth system and the Earth's interior, and all about your studies with the deep, deep Earth. And we have some questions for you. I have them saved for years because I never thought I would have this opportunity. So I'm very excited. And he's not able to stay too long, everybody. He has so many different things to do and run off. He's just a busy man. So, Dr. Rockendirt, oh my goodness. Number one, I'm gonna have to share my microphone so you can hear him. He's a very reserved man. How do you study rocks that are so deep in the Earth's surface?
I drill into the Earth and I also use seismic waves.
Very cool. So we talked about seismic waves, right? Just before he arrived. Oh my goodness. So the seismic waves he'll probably talk about a little bit with that, what that does. And we've talked about it. And he said that they drill. So very similar to what we just talked about. Awesome. Now, can you tell us a little more about the seismic waves? How in the world would they help you identify a new material?
Well, seismic waves bend when they get closer to new material. I have examples here.
So very similar to what we talked about just a little while ago. He's brought some diagrams that he had of seismic waves. When it hits these new structures, this new material, they bend. So that's how they know there's new types of material in the ground. Very good. And Dr. Rockendirt, I see you have another sign here. He brought something else. And, oh, very cool. It looks like he's got one of his famous seismographs on an earthquake. Oh, wow. That's amazing. So we can see where it started out, and then all of a sudden, this crazy activity down in the earth. And look what happened. The waves, this instrument picked up all of these waves. That looks like a pretty major earthquake. I don't know which one it was, but must have been a pretty intense one. Very cool. I love it. Dr. Rockendirt, the question that I've always wanted to ask you, why did you choose to be a geologist?
I like rocks.
He likes rocks. Oh, I love this. And do you have a favorite rock specimen?
I like granite because it has lots of spots.
Very good. He likes granite. One of my favorites, too. Oh, this is just so exciting. All right. So we won't keep Dr. Rockendirt too long, but I have a couple jokes, that I just happen to have in my pocket. What is a geologist's favorite type of music? Any idea? Rock and roll. I need a little drum. Dum. Oh, we might have the dum. Let me read that joke again. I'll give him a minute. He's doing something crazy back here. Oh my goodness, folks. What is a geologist's favorite type of music? Rock and roll. Oh, and he's a drummer, folks. This is amazing. All right, how about one more joke while Dr. Rockendirt is back there? Who would have thought he was a percussionist also? What did the geologist say to his boss? Please don't take me for granted. I love it. Awesome. Well, I'm going to clip this to me. Let's give Dr. Rockendirt a huge, huge, huge round of applause for stopping by. I know he's a very busy man. Round of applause. Round of applause. And Dr. Rockendirt and I are going to post a picture right at the end of this video of a homemade seismograph that we did. So there would be a picture of that. You can check it out. And oh, what a great day. We hope that you guys have a fantastic week, and I'll get him to sign some autographs. I'll send them to you, okay? Cool. We are out.